this worksheet, we're going to practice drawing the SN2 mechanism. So here I have a pretty detailed example of an SN2 mechanism. First thing that we have to do is double check to make sure that our substrate or our reactant molecule is not tertiary. It has to be either methyl, a primary, or a secondary. That means that the carbon that's holding the leaving group, which in this case is the OH, this carbon has to be either primary, secondary, or methyl. This particular one is secondary because this carbon is bonded to 2 additional carbons. And again, it cannot be a tertiary carbon because that will not do an SN2 mechanism. Now, if our leaving group is either OH or NH2, we've got this extra step that we need to add, and we're not always going to need this step. If the leaving group is anything other than OH or NH2, we're just going to skip this step completely. But if the leaving group is OH or NH2, that makes it a bad leaving group. And before we can proceed with the reaction, we have to turn it into a good leaving group. We'll do that by protonating it with an acid. So here's an example of that. We have our bad leaving group here. We have some random acid that's been added to this reaction, hydrochloric acid. Lone pair of electrons on that oxygen are going to reach out and grab that hydrogen from the HCl and then break the HCl bond. That's going to put a second hydrogen onto the oxygen and also give it a positive formal charge, which makes it now a very good leaving group. Now, and again, this is an optional step. We're not always going to do this step, but all the time, the next thing that would happen is the nucleophile is going to attack the carbon with the leaving group and make the leaving group leave. So that's what's showing here. The lone pair of electrons on the nucleophile are attacking the carbon and breaking the bond between the carbon and the leaving group, and substitution is complete. So let's take a look at some specific examples. This one I'm going to kind of gloss over until we actually apply it. No, we're actually probably not going to apply this. If the nucleophile, so that's this thing here, if the nucleophile was charge neutral before it attacked, then we're going to have to deprotonate the product. This is pretty uncommon. You're not going to see an example of this on this worksheet, but you will see it like pretty soon, coming up pretty soon. So here's our first example. Here is our molecule. First thing that we want to do is make sure that this guy is not tertiary. This is a carbon that's bonded to 2 carbons, which makes it secondary, which means that it's good to react. Notice that we have a bad leaving group here, so that means we're going to start by turning this into a good leaving group. We're going to protonate the nitrogen with the HCl. I've got one curved arrow showing the nitrogen forming a bond to the hydrogen, and then I've got a second curved arrow showing the HCl bond breaking. And now I have, instead of NH2, I have NH3+, which is a great leaving group. Then I'm going to bring my nucleophile, which is just the chloride ion, the other half of that HCl. This is where the SN2 reaction is actually taking place. So this part right here is just getting ready for SN2. Now we're going to actually do the SN2. That chloride ion is going to attack the carbon holding the leaving group and then break the bond between the carbon and the leaving group. And that gives us this molecule right here. Here is our next example. First thing that we want to do is take a look at the carbon holding the leaving group. How many carbons are attached to it? It's got 2 carbons, which makes it secondary, which means that it is capable of reacting. This is a good leaving group, which means we don't need to be doing any of that protonation. We can take that nucleophile negative charge on the oxygen and we can attack the carbon with the leaving group and break the bond between the carbon and the leaving group. And now we have formed this new bond to the ethoxide OET, and we've got that bromine. Generally, we don't write the formula of the leaving group, but I'm going to write them in right now because when you're first learning these, sometimes the unbalancedness of these equations can be extra tricky. And then here's our last example. Take a look at the atom holding the leaving group. Make sure that this guy is eligible for SN2. That means make sure it's not tertiary. This carbon atom is bonded to one other carbon atom, which makes it primary. So that means it's good to react. Take that negative charge on the nucleophile and attack that carbon. Break the carbon-chlorine bond. And there's our product. Oh, wait. Almost forgot to include that. There we go.